Yeah, that's fine. Okay. Okay. Hi, everyone. Welcome to Test Generation 1. So we've got 3 talks in this session. Oh, actually, I can play a video button's come up for me now, so that's fine. So we're going to start off with generating accurate assert statements for unit test cases using pre-trained transformers. So I'm going to play the video for you now, and then afterwards we'll have an opportunity for questions. Okay, thanks so much, Mikkel, for that video. So I now open the floor to questions. If you have a question, please feel free to type it in the chat box, and I can read it out. First of all, are you here, Mikkel? Is your mic on? Can you hear me? Hi.
Hello.
Yeah. So okay. Well, I have a question to get the ball rolling. Okay. What challenges do you foresee taking this technique that you've applied to unit tests and applying it to integration or end-to-end tests?
Yeah, that's a very good question. So the challenge with integration testing, I believe, is providing the model enough context to understand the full pipeline. For example, unit test is relatively simple because you can guess the assert based mostly on the unit of code, so the focal method. However, for integration testing, you might need a sequence of multiple methods and or even more project information. And given the model limitation is mostly the input size. Currently, it's 1,000 tokens. So providing all this information to the model can be challenging. So I would say that's probably the most challenging part.
Okay, thank you. Okay, we have a question. Can you elaborate more on why adding new assertions would improve code coverage?
Sure. So basically, the idea is that some test cases might check the basic flow, but might not check other states of the program after the invocation. For example, a simple asset could check the result of the method call, but we could also check the state of a variable with a getter or a setter, or like a public variable. And there are also additional assets that can invoke auxiliary methods, and so we can improve code coverage on that side. Of course, it's an open debate whether you might want more assets in the same test case, or you would rather have a different test case that cover those branches. So yeah, that would be my answer for this.
Yeah, can I have a follow-up? So in that case, basically the assertion also contains some like test logic, right? Because my understanding is like if you do assert, then you just basically check something. You don't even change the behavior of the test. Is it correct or no?
Yeah. So so you're saying that basically assert will not change the behavior and the execution of a method, right?
Yeah, of the test.
Of the test, yes. So I agree. I agree that looking only for code coverage improvement might not be the only good way to evaluate this new assert. So, and some new assert might not just increase the code coverage. Basically, I think one thing that we should improve is basically looking also at mutation score, or like understanding whether we can can catch some bugs using this additional assert. But I agree with you that it's not always just about the code coverage with this new assert.
Yeah, so it's very important, right? If you go beyond like unit tests, like integration tests, then the state will be really matter. Yeah.
Yes, and yeah.
Thank you.
Thank you.
Yeah, thanks for that good answer. So I invite anyone else to ask any questions if they've got them. Okay, all right, one more question from me. So for I can't remember what percentage it was. It was like 64% you said matched the developers' solutions, was that right? And of those that didn't, you said that some didn't match, but they were equivalent, right?
Yes.
So of the ones that didn't match and they weren't equivalent, in what ways would they differ?
Yeah, so what we found was like they were checking different things that what the developer would check maybe like public field rather than the result, or completely, or maybe completely miss the objective of the test case. So that's why like we didn't really count those ones, but yeah, I think most errors come from checking different things that the developers did not intend to check. For example, like public fields.
Okay, great. All right, thanks a lot, Mikkel.
Thank you.
So we'll now move on to our next talk, which is leveraging code-test coevolution patterns for automated test case recommendation. Okay, thank you so much, Samir, for that talk. So once again, I invite the room to ask any questions they might have. Okay, well, I'll get the ball rolling this again. So for your first research question, you use co2vec and then cosine similarity to quantify the similarity between the tests that you generated and the developer written tests. So have I understood that correctly? I think you've muted yourself. I can't hear what you're saying.
Yeah.
Yeah. So why did you choose that approach, which may not really capture difference in semantics between tests? So, for example, you had two tests where the assertion was flipped, so an assert true was an assert false. So that's kind of like the complete opposite meaning. So why did you choose to go for something like co2vec that just purely looks at the source code, as opposed to something that might capture how the test actually works? So maybe something like mutation score.
So actually, coevolution also considers the structural similarity, and that is the part we were focusing. So that's why when they are structurally similar, the similarity score we found were more similar.
Okay. So we have another question. So I noticed that some of the test cases generated by your approach differ from the developer's ones in terms of test function name. Do you have any plans to learn the developer style and preferences for naming?
Yeah, actually, we just wrote it by hard-coded approach. I think I wrote it using prefix or suffix, but developers use different approaches. Yeah, we at the moment we are not capturing any semantic information from the source code, but this is just a very basic step. But we are planning to learn the semantics from the source code and other information and improve the tool.
Okay. So how would you kind of envisage that this would then be used by developers? Would it kind of, could you maybe hook it up to a continuous integration system so that it runs every time the software changes? How do you kind of visualize it having an impact?
Okay, currently it's a Python-based tool. What we are planning to do, develop some plugin to integrate when developers are writing some new source code. Then we might be suggesting some test cases by developing some plugin. That is our next plan.
Okay. Okay. Do you think programming language has any influence?
Actually, the one thing is that we only evaluated it. We got the statistics for Java based, but the approach will still be same. But we don't have the statistics for other languages. So if we want to generalize, we want to conclude that it is not program specific. We have to have the statistics. But currently, we only have done it only Java based. But if the statistics shows us that it is valid, the tool will not be program specific, language specific. The basic approach will also approach will be the same.
Okay, great. So if there's no more questions from anyone else, I'll just give it a minute or so. Okay. All right. Well, if there's no more questions from anyone else, we can move on to our third talk, and that is integration of test generation into simulation-based platforms and experience report. Okay, thank you so much, Luca, for that really interesting talk. So for the last time, I'll open the floor up to questions. Oh, by the way, Luke, I think you're muted.
It should work right now, or?
Yeah, I can hear you now. Okay, any questions for Luca? We'll just give people a minute or two. Okay, well, sorry, Luca, it looks like no one's got any questions for you. I think you pretty much addressed everything in that very comprehensive talk you gave, so thank you for that. Unless there's any last-minute questions, we'll move on to our final talk, which is NSF solicitation on sustainable computing.
I'm here to promote my the event in the main conference of the site. Here is the main conference. This event will be at Wednesday, May 25th. It doesn't give a time, 4:30, I think. Give me a second. It's 4:30 to 5:30. For the proposal, I don't think there's a citizenship requirement, but you do need to have a person in the US, and you could have international funding, but then you have to collaborate with somebody in the US, right? So usually professors that in the US apply, but inside their application they can have international requests. Right, and the professor in the US doesn't have to be a citizen. Doesn't have to. So there's no citizenship requirement for the proposal. So that's to your answer. But you do need to have a US university collaboration. Make sense? Right. So we do have a lot of international collaboration. Any other questions? Okay. If it's no questions, please try to attend this section for 1 hour. We're going to talk about it and discuss this in more details. Right, and here it's my email address. If you have any question you want to reach me, I put it in the chat. And the section in the main conference, it's Wednesday, May 25th, 4:30 to 5:30 at the room 303. Yes. I will just reuse the webinar slides, the one we did in May 4. Right. Sounds good? Any questions, comments? If not, thank you. Thank you for giving me the time to talk about this one.
Yep, thanks so much for that. So I think we've got a couple of minutes before this session is actually scheduled to finish. So perhaps if anyone's got any questions about any of the papers that have been so far, maybe now's the time to ask. If not, then I guess we'll end the session a little early.
Yeah, I think we can end the session early today. And that will also conclude the conference day today. Yeah.
Okay, great. Okay, thanks everyone.
Yep.
Bye.
Yeah, just a quick reminder, like tomorrow we will start at the same time. Yeah, for the second day. The program is on the website. Yeah, feel free to join. All right, so see you tomorrow.
Yep, see you. Bye.
Bye.